Solve the equation log base 4 3x plus 1 is equal to log base 2 x minus 1. So what we want to start off by doing is writing both sides with the same base. In this case we're going to use 2. At the moment we have log base 4 and log base 2, so we want both of them to be log base 2. And in order to change the base of one of our logs, we have to use the change of base law, which is law number 5, which says that log base a x is equal to log base b x divided by log base b a. So what happens with the change of base law is that the x, which in this case would be the number, or in this case would actually be the 3x plus 1, that becomes the numerator, that goes into the numerator, and the base a goes into the denominator, and we no longer have a log base a. It's going to be a log base b for our numerator and a log base b for our denominator. So log base ax will give us log base bx divided by log base ba. So the x comes up here into the numerator, the base a comes down here into the denominator, and the log base a becomes log base b divided by log base b. So the main thing that we have to think about is that we want the b in our formula to become a 2, so that both sides of the equation have a base of 2, so that they have the same base. So if we're starting off with log base 4 3x plus 1, we want this 4 to become a 2. So the 4 in this case is going to be the a in our formula. So we've got log base 4, and we want this 4 to become a 2. So ultimately it's going to be log base 2 divided by log base 2. But obviously we have to bring over the a part and the x part as well. So our formula says log base ax is equal to log base bx divided by log base ba. The a is going to be the 4, so that comes over here into our denominator. And then in our formula the x is actually going to be the 3x plus 1, and that comes over into our numerator. So it comes over here into the numerator. And then we swap the b for 2 in our numerator and our denominator, because we want our bases to match up on either side of our equals. And on the right hand side we already have log base 2, so now we need log base 2 on the left hand side. So this is our formula. It's given to us in the log tables. The base of a was 4, so that comes over into our denominator. The x was 3x plus 1, so that comes over into our numerator. And then we have log base 2 and log base 2. So log base 4 3x plus 1 can be rewritten as log base 2 3x plus 1 log base 2 4. So that's where this step comes from here. So we're going to rewrite log base 4 3x plus 1 to be log base 2 3x plus 1 divided by log base 2 4. And then log base 2 4 can be rewritten as 2, because 2 to the power of 2 gives us 4. So 2 to the power of what gives us 4? 2 to the power of 2 gives us 4. That's where the 2 comes from. Now you could just put that into your calculator. Log base 2 4, it should give you 2, but you should practice the scorpion tail method that I've used in other videos to rewrite this as a single number. So if we were trying to solve log base 2 4 equal to x, trying to figure out what that x value was, we would start with our base, which is 2, and our scorpion tail would wrap around the x, pass the equals, and end up with the 4. So we would say 2 to the power of x is equal to 4. So 2 to the power of what is equal to 4? And it's going to be 2 to the power of 2. That's where that 2 comes from. So now that we have both sides with the same base of 2, so we had log base 2 x minus 1 already on the right hand side. And on the left hand side we now have log base 2 3x plus 1 divided by 2. So now that we have the bases matching, we can solve. So on our left hand side we have log base 2 3x plus 1 divided by 2. And on our right hand side we have log base 2 x minus 1. So all we did was we rewrote log base 4 3x plus 1 as a base of 2, which gives us log base 2 3x plus 1 divided by 2. So the first thing we're going to do is multiply both sides by 2 so that we can get rid of the divided by 2 part on the left hand side. So if I multiply the left hand side by 2, I'm basically just cancelling out the divide by 2 part. But if I multiply the left hand side of my equation by 2, I must multiply the right hand side of my equation by 2. So I'm just going to stick a 2 in front of my log base 2x minus 1, because this really means 2 multiplied by log base 2x minus 1. So what I've done is I've multiplied both sides by 2. So now I have log base 2, 3x plus 1, equals 2 log base 2 x minus 1. Now I'm going to use law 3 of logs in reverse to bring this 2 that's in front of my log to be the power at the end of my log. So law 3 says log base a x to the power q is equal to q log base a x. And I'm actually using this law in reverse. So I'm going from q log base a x to log base a x to the power q. So the q, which is in front of the log, now becomes the power of the x. So the 2 was in front of the log, now becomes the power of x minus 1. So on my left hand side I still have log base 2 3x plus 1, and on my right hand side I now have log base 2 x minus 1 squared. Since I have log base 2 on either side, I can just cancel out the logs. I can only do that because they have the same base. Then I can equate whatever is left. So I've got 3x plus 1 on the left hand side of my equal sign, bring down the equals. And then I have x minus 1 squared on the right hand side, which I'm going to work out over here. X minus 1 squared means x minus 1 multiplied by x minus 1. This is known as binomial expansion, or I can look at it like it's 2 eggs. I'm going to crack open the first egg, bring down the x, bring down the minus 1, and multiply both of those by whatever is in the second egg, which happens to be x minus 1. So I have 2 eggs, I crack open the first egg, I bring down the x, I bring down the minus 1. I did not crack open the second egg, so I bring that egg down here, and then I multiply it out. X by x is x squared, x by minus 1 is minus 1x, or just minus x. Minus 1 by x is minus x, and minus 1 by minus 1 is plus 1. Minus x and minus x is minus 2x, so I end up with x squared minus 2x plus 1. So that is where the x squared minus 2x plus 1 came from here. Now what I want to do is bring everything over the same side, but I want to make sure that my x squared stays positive. So my x squared was already positive and it was already on the right hand side, so I'm going to bring everything over to the right. So I'm going to keep the x squared minus 2x plus 1 on the right. I'm going to bring over the 3x and it becomes minus 3x. I'm going to bring over the plus 1 and it becomes minus 1. So on the left hand side I now have 0, then I have equals. The x squared just stayed the same. Minus 2x minus 3x is minus 5x, and plus 1 minus 1 just cancels out. So I end up with 0 equals x squared minus 5x, or I could have written it as x squared minus 5x is equal to 0. Same thing. Now remember, I was asked to solve this equation, and to solve I want to get the x on its own. So the first thing that I'm going to do is I'm going to factorize. So I'm going to take out the highest common factor of both terms, which is going to be x, and I'm going to say x into x squared leaves me with x, and x into minus 5x leaves me with minus 5. And I can just check, am I right by multiplying this out? X by x is x squared, x by minus 5 is minus 5x. So I'm left with x times x minus 5 is equal to 0. Now I'm going to let what's outside the bracket equal 0, so literally just x is equal to 0. So I found one of my x values. And then I'm going to let what is inside the bracket equal to 0. So x minus 5 equals 0. So x is going to equal to positive 5. Now I found two values of x, but I need to check will either or both of them work. So if I was to sub in x is equal to 0 into my log on the right hand side, I would end up with log base 2 0 minus 1, which would give me log base 2 minus 1. So that's not going to work because we cannot have a negative inside our brackets, because a negative log cannot be defined. So 0 is not going to work. I'm not even going to bother subbing it into the left-hand side of my equation, because if it doesn't work in one of the logs, it's just not going to work. So now I'm going to try x is equal to 5. So if I was to sub in x is equal to 5 into the left-hand side of my equation, I would have log base 4, 3 times 5 plus 1. 3 times 5 is 15, plus 1 is 16. So that would be a positive inside my bracket, which could work. And now I'm going to sub in x is equal to 5 into the right-hand side of my equation, which would give me log base 2, 5 minus 1, which would be log base 2, 4. And again, I would have a positive inside my bracket, so that would work. So x is equal to 5 is okay. X is equal to 0 is not okay, because we would end up with log base 2 of minus 1. And we cannot have a negative inside our bracket. We cannot have a negative log. It cannot be defined. So our answer is literally just going to be x is equal to 5. So we were asked to solve the equation. Solve means to find x or get the letter or get the x on its own. And we found our x value to be 5.